Something that I found cool yesterday, and it came from Anton Petrov's video on second laws of thermodynamics being challenged by a tiny quantum engine. And this was a very cool idea, and I started looking at the article. So this is basically applying the whole idea of thermodynamics in regards to movement and, well, fluctuation of particle within space with temperature and using the Hamiltonian in order to relate the original equations, well, the classical equations for thermodynamics to the quantum realm, which I found pretty interesting. This is stuff that I still haven't even learned about yet, with the Carnot formula being that weird N C equals 1 minus temperature cold, like the two bath temperatures, temperature cold relative to the hot, where T, C of H are the respective temperatures of the cold and hot heat reservoirs or baths, as I'll mention later on. But I mean, classically, it would be heat reservoirs. Quantum definition would be bath. And a Hamiltonian meaning of force. And the results were very interesting. I mean, considering, sum equals the Hamiltonian total when it comes to the quantum aspect of everything. And it's time dependent, so taking into account interactions throughout time as well as periods, so fluctuation. And then we get this equation: work equals Q of J plus the change in U, or the sum of J, where Q of J is the Hamiltonian multiplied by that adjustment for time in respect to time. We also have another work formula up here, the integral from T to T plus the period, so 1 period of revolution, with the second derivative, dt, so the change in t, the derivative of that, times the partial derivative of t in respect to the Hamiltonian total up here, and derivative of t. So this is where I start getting confused, because this Ernst's theorem for H total. So this is more Hamiltonian Lagrangian stuff that I haven't learned yet at all, and I'm still kind of trying to parse, but the general idea of it, with how this describes quantum systems as it relates to non-equilibrium entropy produced during the cycle of duration, so the period, here expressed as the amount of correlations between systems and baths. So systems being the quantum particles or the indices that exist within space, and then the baths being the environment. But it is non-negative and hence quantifies the irreversibility of the process, because, as we observe with the quantum field, that there are certain particles that don't really interact with typical forms of matter. They don't interact with atoms necessarily. They just exist and make up space. Photons don't necessarily interact with atoms. Same thing with neutrinos, and I don't know if gluons really do, because that's the relative to the strong force that holds certain particles together, and then relative to the bosons, and etc. So it's just so many factors, but this way of thinking is kind of interesting, and it's good, because we were also considering, and what has been considered, is electromagnetism, as physics explained runs through how that,
Now,
it
at first,
has an equation, but it seems to fall apart, because we got A of G, or alpha G, and if we start subbing in Einstein's equations with gravitational constant relativity and all that good stuff, with energy, we get something relative to the Planck energy, which is, it's the inverse, the square root inverse, so it's very interesting. But then we have a way of relating the energy of the system relative to the Planck energy. So the total energy relative to the smallest possible energy. And this is where, we get huge numbers because of just the scaling. It's squared. So, but as E approaches E to P, the Planck energy, which is, the maximum amount of energy in the universe, alpha G tends to 1. But that's the moment where things tend to break. And honestly, I think this is the limit of the quantum space. This is what differentiates space from other forms of matter, is this limit. I don't think it's a bug. I think it's a feature of using electromagnetism and analyzing quantum mechanics in that way. And this is where it kind of lends to some similarities with my thesis, as this is kind of the way I wanted to work and figure out how how time is decelerating with this sort of relativity, because we have the maximum energy at timeline 1, timeline being the most possible time, and then at that point, this is relative to the entire universe. When we have the total amount of energy that exists in the entire universe in one specific point in space, that's the Big Bang. That's squared. That's why this breaks, is because in that moment, things cannot exist for an extended period of time. It only exists in an instance. Therefore, this energy has to be dispersed relative to the Planck, and then, relative to the quantum realm, there's also a way of limiting eigenstate measurements as well. So I feel like perhaps this, being recognized as the true limit of quantum space, as space is relative to what exists or what used to exist, as space is made up of particles left behind from interactions within space, and more space is being produced as more complex forms of mass energies and matter interact throughout space over time, as time depends on stuff that exists, complex things existing within the universe that were created from the very beginning, and then from the cooling of the Big Bang. So throughout that process, in that instance, following, perhaps this law right here, or this equation. So that, I don't think is, like I said, I don't think it's a bug. I think it's a feature. It's something that we can consider from a limit of 0 to 1, where, you can still have 0 energy relative to the Planck energy, and that's nothing. That's basically entropy at that point, and you have 0 acceleration. Time isn't going anywhere anymore, because that's what we're looking at, is the acceleration constant of gravity, or what's causing the momentum, which is the force that's accelerating objects in space. And it requires energy relative to the Planck energy in regards to the entire universe. So that was interesting when I saw that, and that's how I kind of see it. And then when you look at the quantum realm, you see how small energies are. The Z is around 10 to the 4 giga electron volts compared to the Planck energy, which is supposedly the maximum energy in the universe. Now, in regards to energy, it's also considered in the thermodynamics, because thermodynamics is the movement of energy throughout space. As heat is released, it's free energy. Well, not free energy, but it's energy from a reaction. And in order to account for efficiency, which is what this model represents, is being able to calculate that release of energy into space and throughout space, because it's the thermodynamics of quantum mechanics. At least that's in principle. So that understanding of thermal and athermal engine operation, as reality tends to go toward entropy, this is also interesting, because if I overlay this with my thesis, it's a very, very interesting, because it's from 0 to 1. It's very, very synonymous, and it just weirds me out, but I feel like it supports at least the the basis for the thought. So let's take down the winding road real quick to the website. I never have this bookmarked. I should just bookmark this damn thing instead of doing this. It probably would have been faster to go through my YouTube page, which this website's also linked on, or on Twitch. Go sub, like, follow, whatever. But yeah, interesting things start to happen when we look at these graphs. If we look at this one quadrant, how I measure things from 0 to 1. So this one's actually a really good example because I highlight, oops, it's gonna fight with me, but I highlight right here this area and this area. And previously I was considering that to be the work necessary to transfer complex forms of energy into space, right? This third, as it relates to time, as this midpoint and these bounds dictate time, right? Depending on how big the circle is, the more energy and complexity that exists relative to what's possible for in regards for transformation and interactions, which should be one-to-one when it comes to reality, because things inherently react super deterministically when we analyze like movement, or in the classical setting, when we analyze things within our local realm of perspective. And then looking at this compared to this, it's interesting because right here we have that midpoint. So boom, boom, from 0 to 1, 0 to 1. This was essentially the relativity or the relative aspect that I was considering. Because if I shifted this down to here, so it would be, I mean, the midpoint here to the midpoint here, this portion would reflect exactly this part of the circle. As I said, that maybe inverses might be involved in calculating consciousness itself, as well as the flow of the universe, and, you know, a more accurate way of describing time dilation, taking into account the error that may be introduced within quantum space due to wave fluctuations in space, and trying to account for all the other forms of stars and everything else that are releasing more particles into space, creating more space from one object to the next, while there's also real gravitational pulls coming from, I mean, black holes as well as other large forms of complex mass. And it's really cool when you consider, well, maybe the inverse has something to do with how that works. And not even just that, when we look at this graph, if we consider a line going from 0 to 1 right here, as it states here, when we consider time, like the timeline of the universe, like how I consider it, this being the point of the Big Bang, that's the hottest point, right? That is where the most heat, and then it dissipates throughout time. This coincidentally follows the cooling of space itself due to that thermodynamics. As time goes on, space gets cooler and cooler, as we have observed, as we have measured, especially different regions of space depending on, you know, what exists. And because of this thermal, well, conductivity that happens throughout space, the thermal spread, I mean, stars release heat, they release it as well as radiation throughout space, and that heat excites the space. But what also excites the space is the particles coming from said stars, which is dispersing more particles and creating more space. So it's kind of like insulating itself in a way, or dragging itself down due to that. Or it's interesting, or maybe that explains why heat only travels so far in space, because we can see stars, right, from billions of light years away, but we're not feeling that radiation, we're not feeling that heat. There is an inherent drag of the universe. So calculating for that drag might also calculate alongside with electrodynamics, well, electromagnetism, that deceleration of space. Or, well, the acceleration of space expanding, but the deceleration of time, I should say. Because as things, go toward entropy, more and more things react and break down to become less complex, and they break down further. And even with some observations of particles in space recombining, like electron clouds, for instance, because those are particles that also float in space, but they're electrically charged, which that explains kind of the bridge, as I think there was one other report as well recently of a possible dark star, which is a giant electron like cloud or giant cloud of atoms that ends up collapsing on itself and creating a new star. So that theory and phenomena, this might also lend to maybe explain that, because it has to do with heat, and then same thing with black holes. So I wrote down my thoughts at least, and I'll just read them straight off. I have a few ideas that stem from this sort of relationship with thermodynamics being utilized within the quantum realm. I've been considering the same relationship myself prior to seeing this, because I wrote a letter in regards to that article that we were just going over. I feel like there is something there, because this was something that I also theorized and considered, I think about a month or two back, when it relates to black holes and how smaller black holes exhibit more heat. Like there's less insulation, there's less push and density of space taking up, where that singularity, the heat from the singularity itself, which is supposed to be, leaning toward infinity, or maybe the Planck scale realistically, or something, because when you compress something, it heats up. Compression and expansion, the laws of thermodynamics, right? And we see that within black holes, they're releasing particles, they're releasing radiation, and fundamental particles, as well as antiparticles. So it's like I theorize in a sense that, black holes are personification of extinction, personification of reaction, that release particles from, a dead star, a star that is not able to stabilize itself within space and be able to keep specific atoms at bay from reacting with each other. Atoms that are more excited and attracted toward each other than things that are easily more accessible for those atoms to interact with. When stars run out of hydrogen and they start decomposing, or, well, oxygen, or whatever other elements make up stars, as well as relative to their size and brightness. And then inversely, black holes are relative to that size and brightness, depending on the critical mass that creates the event horizon and the Schwarzschild radius. So considering that and understanding the thermodynamics of black holes inversely to this quantum law of, or analysis of thermodynamics with the first and second laws, and then also considering entropy of the universe, as well as maybe considering, as I've stated previously as well, that this is complex matter, or just all forms of matter, including dark energy. We can also consider it within this framework, because this framework utilizes all different aspects of mathematics, fundamental mathematics. Consider this all forms of matter, including dark holes, all forms of things, mass energy. This is space. Or photons, massless forms of energy, or any other massless particles. I think some bosons are considered massless, as well as, neutrinos, they stretch out over time. They also help us understand the age of the universe, because I guess all neutrinos are kind of relative depending on where they're left in space, as well as when they're left in space, which that, like I suggested before, is similar to carbon dating and how we date the age of the universe, because we observe neutrinos with lower and lower electrovoltage values, lower energy values, and that's how we can relate to fresh neutrinos that we've observed from reactions on Earth that we have forced through particle accelerators. And there we can kind of roughly guesstimate an age of the universe and looking at as well as primordial black holes. But regardless, space can be considered as a potential energy for the next Big Bang, whereas all forms of complex mass energy, all forms of consciousness with mass, all forms of energy that hasn't reached, or all forms of mass that hasn't reached entropy within space, still have some sort of complexity that is still, ongoing. That's the kinetic energy. That's what's acting within the universe that's giving us the flow of time. So, and then we have an isolated system right here between these four quadrants, with these two being connected relative to these two, using, like I said, the values of I and, well, -1, -I, and then utilizing complex numbers, just like formulations of quantum mechanics utilize complex numbers in order to understand uncertainty and probability, like Lorentz, for instance, or Heisenberg's uncertainty principle, as well as how Dirac utilizes I to also consider all different possibilities of spin, right? The multiple different answers to Dirac's equation that show different possibilities of spin utilizes I in those equations. So that's using imaginary numbers, it's using, how we relate circles to one another, how we have a framework, how it follows along a timeline, and all these axioms, allegories, postulates, whatever, relative to all these different ways of math, just like how they figured out thermodynamics by pressing the Hamiltonian against laws of thermodynamics in order to translate it into the quantum space. And then using indices similar to Schwarzschild radius and other, not Maxwell's equations, but other ones. There's just so much of it that I'm still personally learning and parsing through in order to, I mean, piece it all together. But that, by the end of the day, that is what physicists are doing. They're taking theories of old and expanding on them, or applying them similarly to what I'm doing. So, hello, fellow physicists. Yes, that it's not a wannabe. I'm just trying to figure this shit out. But regardless, I think it would be interesting if we took a look at the inverse of this order right here, which if we flipped it, it would also lend to be a part of the circle, and it would be against the hottest point in time. And then as that heat dissipates, that moves down, so that clamps exactly as I described here. Is that, imagine if that just kept going, upper bounds are being spent, and then moving into this other realm. Depending on your consideration of transformation and considering local causality, as thermodynamics explains fundamentally local causality, because it's interaction of a particle with its environment, or of a reaction with its environment, like how we understand efficiency. So that's probably the best part about this sort of way of thinking, or at least application. And it was kind of like how I theorized, except I just don't understand all these different aspects of quantum mechanics. I've only been studying quantum mechanics since January. It's a lot, and my personal background is only up until like differential equations, but I barely understand a Lagrangian and Hamiltonian enough. So trigonometry as well, I'm still brushing up on and doing better. But with how sine is relative to the movement of quantum spin within particles because of Dirac, as well as this is the second part of the movement involved with particles, as this will explain excitation of particles within space due to the effect from one reservoir transferring energy and heat through that particle into the other, tending toward, entropy, as the universe tends to. And then this is with some exploits. You can exploit these 8 thermal resources depending on the chosen parameter values, show the normalized logarithm. So this is, again, using law. This is exactly how I was kind of considering it. So the 8 thermal regime violet clearly dominates the thermal regime orange and occupies more than 87% of the parameter space. which that's very interesting. And the black circles represent the numerical determined boundary between the two regimes, thermal and athermal. So there's that number there, and this is like kind of a close up where we get a shift in that parameter space and boundary. So thermal efficiency, right? And this will be cool to implement this into a supercomputer alongside, because this is basically giving a supercomputer a way of understanding interference in and of itself. It's able to compensate for the excitation, the movement of particles around itself due to the heat that's exists around it. Because that's in order to maintain, I mean, qubits, that has to be toward absolute zero, but I mean, we can get as close as we can. We don't typically get at absolute zero. So there's going to always be some inherent error. Or even then still, even if we get to absolute zero, it's only maintained, I mean, there's fluctuations. There's always heat within its immediate environment all around it that's affecting it. So, I mean, the other thing too is radiation. And this was a consideration because I was also considering like maybe running these sort of things like particle colliders and looking at this type of stuff in space, but I also kind of remembered, or well, also learned more about why the atmosphere is very important on Earth. Because with the atmosphere, it protects systems that rely on electricity and current from the radiation of the sun and electromagnetic effects of the sun. Because even though it seems like we're far away, those effects do affect our electrical systems, as we're finding out more and more each year when we have giant holes getting bigger in our atmosphere that's allowing more of this electromagnetic radiation to affect our systems, destroying our satellites and doing all sorts of other stuff. So I think the environment is probably playing a even bigger role in figuring all this stuff out, and it's probably going to be a bigger consideration. But even when we see, you know, these formulas being used in order to, you know, figure out efficiency of quantum systems, and this is interesting. So we're able to really, I mean, classical entropic term, but entropic term with the period. Can I zoom? Yep, and change in what, sigma? So we're able to get more accurate, more athermal resources, which, I mean, it will help in quantum systems, especially if you want to run a system that is artificially conscious and sentient. So very cool. But I think between this and electromagnetism, that would be quantum gravity in and of itself, because there's charge, but charge is mostly relative to baryonic forms of matter. I mean, there's also the boson charge and some antiparticle charge, but that lends more towards spin rather than actual charge. So I think that's where using both formulas in tandem, maybe using how we calculate electromagnetism relative to quantum mechanics to find the limit, which would explain why space is space and why matter is matter, or atoms are atoms, right? That would explain why they're two different things, and why we have classical mechanics that we started with and are using the same rules with some transformations in order to explain quantum mechanics, because that's basically how it's been done. Besides the uncertainty principle, which, I mean, relates probability, which is also considered in classical systems when it comes to error. So yeah, very cool stuff. But I'm gonna leave links to this, the quantum, well, the physics explain video why quantum gravity doesn't work when applying electromagnetism, and how these laws of thermodynamics are very interesting. And I think there was also one more part of the article where it comes from, I mean, conservation of mass energy. The efficiency of an engine operating between many reservoirs is upper bounded by N being less than or equal to NC minus KT, minimum change in sigma over Q in. So the indice and then bath's temperatures, sum of that. Sum is going to be greater than 0 or greater than equal to the 0, because I mean, space itself has a temperature. There is still energy within space as long as things exist within space. As long as more complex forms of energy and mass energies are still existing, because they're constantly shedding energy every moment, every second of the universe through, I mean, natural decay of atoms and just interactions in space. No matter what, it's not all spent yet, especially since we can't measure all the atoms that still are in space, in all of space. We can't measure, well, we can maybe get close to measuring the current, the actual true current amounts of available energy left, the current state of all the stars that we're observing right now. You know, adjusting for movements of all stars, but that's so much for one system to handle. So much for one person to handle, let alone even a team of people to handle. But with these equations and relying more on, I mean, artificial intelligence and working through this, I mean, within the next probably year or so, we might actually get a theory of quantum gravity that works, and as well as artificial consciousness. I mean, I'm kind of calling it, because that's at least what the end goal is for a lot of people when it comes to this sort of thing. The numerical simulation, so when you actually put in numbers and run the numbers. But yeah, definitely check this out. Check out Physics Explained video, check out Anton's video, and let me know what you think. I'm just gonna, I guess, finish off reading what I was gonna read. I mean, since this relates to explaining excitations of quantum space as a consequence of interactions of forms of mass energy and particular particles as an explanation for the environmental effects from the rotational energy of the particles relative to indices versus baths, could this be linked alongside electromagnetism, as though by itself does not explain the consequences of interactions, but rather as electromagnetism relates to the driving force of interactions that contribute towards thermodynamics, because spin, that's what electromagnetism loosely explains is, I mean, the spin, the energy from spin of a given particle, and we can compare that to Planck energy, and then how that contributes toward interactions from particle to particle and interactions within space using these rules of like quantum ideas and concept of thermodynamics as they go towards a higher energy state or higher state of entropy or lower energy state. As space continues to expand, large forms of mass energies either move further from each other or into one another. I haven't been paying attention to chat. What else is new? Nothing new. All right, cool. Anyways, larger forms of mass energies either move further from each other or into one another, thus breaking down through those interactions, leaving behind more particles into space, and thus further spreading the releasing energy into space, exciting it, but spreading it over, spreading out over it, simulating the flow of time and its deceleration as less complex forms of mass energy are taken out of existence of form but transformed into smaller, more quantifiable forms, or quanta. More simply, utilizing electromagnetism and thermodynamics and their respective inverse, says, to find a better understanding of the interactions of both spin from particles relative to each other at any given point in time, and the movement of thermal excitation as that energy is dispersed throughout its neighboring particles, such as photons, bosons, gluons, not gluing, not correct, gluons, electrons, through local causality, because, I mean, thermodynamics explains local interactions of energy distribution throughout space. So within spin as a factor of consideration of transfer of dispersal towards entropy, as space still withholds excitation due to the complexities that still exist, which would explain the temperature of space not being absolute zero. and it's trending towards absolute zero as time goes on, and interactions create more space and disperses more kinetic energy, following the second law of thermodynamics. Moreover, such a connection may also help to understand the temperature of the singularity of a black hole, as well as inversely to the radius of the Schwarzschild radius of the black hole relative to its mass, or its mass. I mean, the density is toward infinity, so it's going to be relative to its mass with that consideration. Explaining how larger black holes insulate. Jesus Christ. Insulate the singularity, while smaller ones allows for the singularity to disperse more rapidly, as there is less insulation due to the mass density not spreading out space far enough, therefore observed to be much hotter as the radius approaches the point of singularity. Lastly, the understanding that quantum systems could regulate more efficiently with this formula in regards to artificial consciousness, taking us closer to the engine of AC that I theorized considering classical Newtonian physics relating to the quantum realm. Besides that, also speculation of a theory of quantum gravity deriving an explanation for time dilation alongside a consideration of the consequences of Lorentz transformations and boosts as a way of correcting the Hubble tension and cosmological constant to be the cosmological variable, as I've been stating for a long ass time. I just don't know enough about quantum physics. I have to do it by myself, and mind you, a lot of these people are fucking teams of people. Anyways, inversely to the chaos of probability in regards to the timeline of the universe and time being dependent on what exists within the universe at any given point in time, these ideas stemming from considering space as potential energy for the next Big Bang and baryonic forms of complex matter, from protons to atoms to molecules to large forms of mass energies, including black holes and dark matter as personifications of reactions, extinction, and moments of extreme interaction densities derived from the effects of simultaneous interactions taking place within a point in space, which is also an observation of time dilation as the kinetic active energy that drives the flow of time within the universe, thus meaning there exist upper and lower limits of the universe in terms of energy, and therefore can be considered an isolated system following thermodynamics laws on conservation of mass energy as the sum of space and matter that exists at any measured point in time equals to the amount of total possible amount of energy possible within the universe, only experienced simultaneously at the moment of vacuum collapse. When all the space exists and there's nothing left that's complex, like there's no atoms left, when there's nothing but photons as theorized, when we get to that point, when there's nothing but massless particles and no mass for the bosons to interact with, or no mass to be defined by bosons, no energy because all energy has been dispersed into the fabric of space itself, right? Because I mean, if you go to the borders, per se, if you go to the borders of the universe, where we have like a lensing effect when we try to look at the edge of the universe. I mean, there is an observable edge of the universe in some way. There's no way for us to physically test if we can go past it or not. There's no way to really look at that. But it's interesting to at least consider that the vacuum effect, the vacuum of space must exist within a closed system of some way to be a vacuum. Even though there's stuff within the vacuum, but even in like a vacuum on Earth, when you suck out all the air, there's still quanta that remains that exists with. There's still space that exists within it, and there's still possibly other atoms as well. There's other things you can run other atoms within a vacuum. The vacuum doesn't collapse; it still exists. So just like the universe, things exist within the vacuum, but the vacuum is so big, the ratio is probably keeping it stable, just fundamentally, because it's based off, time is based off quanta within the quantum realm, and quanta is within everything, it's within the atoms, and because of that stability, things can exist over time. So, in the occurrence of the Big Bang as the only means to recombine the entropic state of the universe at the end of time, 0K. So, again, when there's nothing but the fabric of space, there's no mass left because all of it's been dispersed as energy throughout the universe into particles, fundamental particles, neutrinos, what have you. And even the neutrinos at that point, we might have to wait until they all spread out into nothingness. The newest neutrino, if we can measure neutrinos that have existed before, but maybe even the oldest neutrino might still have energy within space, but it'll be so small in comparison to the last neutrino ever created. That maybe, just maybe, that might be why the vacuum collapses. Because if there's only photons, I mean bosons, I suppose, there's no protons, there's no electrons, because they're all broken down into neutrinos. For whatever reason, electrons part with a neutrino when they react with things. So as a trace, so there's always a loss that goes out into space. That wasn't meant to rhyme, but it did. So interesting considerations, but maybe that's why the vacuum collapses, because of the difference in charge throughout all of space that's left, with no mass keeping that charge at bay from collapsing in on itself. Maybe, but this would be a step toward maybe explaining that, and the vacuum effect may also be explained only relative to the effect being able to act upon mass in existence. With no mass to act upon, the true vacuum is realized as a false vacuum and collapses at the moment of the end of the big freeze, as nothing is left holding space from collapsing in on itself. This is only why, well, this is also why we do not observe space becoming baryonic matter, typically. Only particles with charge that can interact. Because, I mean, even if, like, electrons, like charged particles from space, end up creating stars, like from a dark star into a sun, something like that, because just consolidation of charge density within space, a lot of electrons and protons, free protons, just collectively coming together and becoming something, then maybe. But once all those are broken down further into all the other particles, especially photons, because it's just going to keep making more photons and more photons and more photons. So that's also interesting. It might also explain why, I mean, we only have photons left at the end, and how they somehow all recombine in one instance, maybe alongside with neutrinos, in order to create the universe again, the Big Bang. So, or other forms of mass energy too small and weak to interact with classical electromagnetism remain as the overall makeup of space. So even if things reform within space, there's still space left behind. So this could also maybe explain why things after the Big Bang existed and things in space existed. Because after that reaction, there was space left behind. And that space gave that reaction to spread out, creating more space. As that's the whole time dilation idea, or well, the acceleration of time at the very beginning, and then slowly expanding, fizzling out. Some areas interacting faster with others. Some areas of space not having anything happening at all. It explains, where everything is in the universe. So, interesting. But lastly, these are at least some of the ideas I've been considering, and hopefully it can give some sense of direction to those more familiar with the nuances of quantum mechanics. I still have more to learn, as I've been saying. But seeing this after 10 months of work, these ideas, and furthering my own understanding of these mechanics gives me hope, and that maybe we're collectively getting to a true theory of everything as existence equals plus and minus truth over time equals negative existence or extinction, and forms of actions being initial action, reaction, and non-action equal reason plus intent relative to effect and cause relative to the Lagrangian and Hamiltonian methods of derivation, as I've kind of recently noticed, because the Lagrangian is, something plus something equals the Lagrangian, and Hamiltonian is something minus something equals the Hamiltonian derivation. Those two ideas, because when we look at reason and intent, I mean, reason typically always exists in some way, shape, or form. Things, as we discover, don't happen for no reason. The more and more we learn about quantum mechanics, the more we understand the reason behind the existence of everything. So that will always be there. But whether it has intent or not, if there's intent, Lagrangian may apply. If there's no intent, it's just, how they applied the Hamiltonian to thermodynamics, as just an inherent reaction with the environment, then the Hamiltonian applies. And maybe, just maybe, that's the philosophical connection that we need to find quantum gravity, as well as to find the cosmological variable, as well as the correct Hubble tension, as well as to be able to completely measure everything in space. So, and that's where your efficiency comes from, as well as to create artificial consciousness. And if an AI system can read this, can understand this, has access to this information that I'm spouting now, especially an LLM that can understand language and be able to work through this, I mean, I don't see why it won't be able to sustain itself at that point in a closed quantum system and be able to adjust for error and for efficiency, and then making it more accurate in its decisions and really allowing it to hold 100% to the truth of reality. I don't know, but let me know what you think. That was a lot. Oh, hey, what's up? Sorry, I was spouting off with a lot of random shit, but oh, you might not even be here anymore. Oh well. Well, thanks for stopping by though. I was spouting for like 20 something minutes. I'm sorry. Uh but anyways, like if you like, sub if you sub.